Welcome, everyone. Afternoon for most people, still morning if you're on Pacific time. We're excited to get going, but we'll give everyone a few minutes to join us. My name's Shala Piper. Was that you, Amy? Did you want to jump in? No? Okay. So just as we're waiting, this is the first focus on wildfire that the CCLM webinar series has done. So we're really excited to have wildfire experts joining us today as our presenters. They have a couple of questions for a panel discussion, and then we may have opportunities to address some questions from the audience as well. We're using a new platform this time, which has a Q&A function. So just bear with us as we learn this new Microsoft Teams platform with the new Q&A function. And if you have any issues with it, please just post a question there. And we have Amy and Kristen and Jesse all doing tech support to help everyone engage with that function. Excellent. Well, I'm sure a few more people will join us, but some of my opening remarks are just a bit of a background on the CCLM. So I think I'm going to jump in. Welcome again. Good afternoon, or if you're on Pacific time, good morning. Welcome to the CCLM's Wildfire webinar. My name's Shala Piper, and I'll be your host today. It is with respect and gratitude that I acknowledge that I live and work on the traditional territory of the Siouxwet'en people and the Métis Nation Region 3. I realize, though, that we are gathered today from the lands of many traditional peoples. So if you can just please take a moment and be aware of the land that you're connecting from. The CCLM is committed to respecting and elevating Indigenous knowledge, lifting up stories of Indigenous-led conservation, and working together to steward and manage land for future generations. Thank you for joining us today for this important discussion about wildfire. Before we jump in, I'd like to say a few words about the Canadian Conservation and Land Management Knowledge Portal. I hope everyone on the call today has had an opportunity to visit the website and use this search function to help you find resources. The CCLM was launched back in April of 2020 and was built with the vision to connect practitioners working across Canada's diverse landscapes to both current and very relevant resources to help them in their work. In 2019, 5 original collaborating organizations came together and identified that there was no central place to share and exchange information and learnings in conservation, land reclamation, and restoration. These founding members included Inotech Alberta, ECCC, represented by the NBCKC, which stands for the National Boreal Caribou Knowledge Consortium, Natural Resources Canada, specifically the Canadian Forest Service, Ducks Unlimited Canada, and NATE, or the Northern Alberta Institute of Technology, specifically their Centre for Boreal Research. Thank you to all of those collaborators, many of whom are on the call and helping as the subcommittee to run this webinar. And we also want to thank our other supporters who have kept the CCLM portal active and growing, including Pathways Alliance, the supporter of these knowledge exchange activities, Alberta Innovates, the Grand Prairie Regional Innovation Network, Alberta Land Use Knowledge Network, the Northern Caribou Canada Portal, and Fuse Consulting. The result of this collaboration has been to create this powerful go-to site for all things related to conservation and land management. There are now over 3,500 resources within the portal, and this number continues to grow daily as we grow in our membership. It has 4 main hubs and has welcomed over 65,000 users since it was launched. We've recently added this Indigenous-led conservation hub, which we're excited about. It brings together and spotlights Indigenous leadership and conservation on existing platforms. Now, if you're thinking that you would like to also be a part of this, or if you'd like to share your resources to be linked in this tool, please feel free to reach out to us after the call, and we can figure out how you can best be part of the CCLM. We are pleased to be hosting today's panel discussion on wildfire. As I mentioned, there are some questions for the presenters that we'll have a panel discussion about. And if there's time, we can also pose some questions to our presenters from the audience. So feel free to contribute into the Q&A function. The moderator for today's Q&A will be Jessie Lavallee-Whiffen. Jessie is the Conservation Program Specialist with Ducks Unlimited Canada in their Boreal program. We have 3 presenters joining us today. Our first presenter is Dayal Wijayarathne. Dayal is a professional geoscientist and an experienced researcher with extensive expertise in hydrology, hydrogeology, and environmental sciences. He's currently with Inotech Alberta, and Dayal specializes in leveraging hydrologic, hydrogeologic, and modeling tools to assess the impacts of natural and anthropogenic developments on water resources while developing innovative solutions to environmental challenges. He is passionate about knowledge sharing, and Dayal actively engages with communities to promote sustainable water resource management. If you are ready, Dayal, please go ahead with your presentation.
Right. Thank you, Shara, for inviting me, as well as for the kind introduction. So, yeah, my name is Dayal Wijayarathne, and I'm currently working as an experienced researcher with Inotech Alberta, focusing on water resources and environmental impacts. Today, I'll be discussing critical yet often overlooked impact of wildfires on water resources. Next slide, please. Yes, I'll briefly talk about Inotech Alberta. So Inotech Alberta is a government-funded research organization and a subsidiary of Alberta Innovates. We operate in 4 communities in Alberta: Edmonton, Darwin, Vancouver, and Calgary, and also there's 1 facility in Victoria, BC. Inotech Alberta is organized into several branches, and we are under Environmental Impact Research and Risk Evaluation within Environmental Services Division. We, as a group of water researchers, we use different tools to investigate the impact of both natural and anthropogenic developments on water resources. Next slide, please. All right, so before I move on to the rest of the presentation, I would like to take a moment to acknowledge and honor the Indigenous peoples who have been the stewards of this land for countless generations. We are grateful to live and work here, and we honor their wisdom, resilience, and continued contribution to these lands and communities. Thank you very much. Next slide, please. Let's delve into the status of wildfires in Alberta. The map to the left shows historical wildfire perimeter date from 1931 to 2023. As you can see here, the area impacted by wildfires is significantly higher in central and northern Alberta compared to southern Alberta. And 2 graph, like to the right, shows wildfire statistics, basically number of wildfires and area burned in hectares within the last couple of years. As you can see here, the number of wildfires and area burned in hectares have been increased significantly during last couple of years. So posing risks to day-to-day life as well as to the environment. So next slide, please. Yeah, so why this is important? So as we all know, many counties in Alberta receive several wildfire advisories during summer periods. So heat from wildfires can cause physical, chemical, and biological changes to the soil, vegetation, and organic matter. The ash mixed with topsoil layer can produce this hydrophobic layer, reducing infiltration rate, hence increasing runoff and soil erosion. This leads to increased sedimentation and water resource contamination. And combustion of plant materials can release harmful chemicals such as heavy metals and polycyclic aromatic hydrocarbons. And those pollutants or chemicals can be transported by runoff and put it into like surface water bodies like streams and lakes. These wildfires are becoming like severe and more frequent due to the impact of climate change, adding more pressure on water resources. Also, Alberta hits a record high interprovincial migration rate during past couple of years, and increasing population will definitely increase the demand for water, adding more pressure on the water. While the impact of wildfires on forest and wildlife is very well known, the influence of wildfires on water resources is less recognized, but yet equally important. So as Innotech Alberta Research Group, we decided to examine this issue, and the solution we came up with, like comprehensive characterization of the cumulative effects of wildfires on water resources. So next slide, please. All right, so wildfires drastically alters the entire hydrological cycle and impacts both quality and quantity. Wildfires increase this burn landscapes introduce high sediment and nutrient loading, as well as heavy metals and toxic compounds, increasing the water treatment cost. And also this wildfires increase the water temperature, and this increase in water temperature can impact habitats especially. And also like this chemicals can leach into groundwater, changing and shifting groundwater chemistry. And also this like, when it comes to surface water, so like we can see the change right after the wildfire, but when it comes to groundwater, in order for this contaminant to show up in groundwater, it takes like sometimes weeks, months, and even years. So it's a delayed contamination effect. And quantity wise, so like wildfires increase runoff and increase like peak flows, causing flash floods in the lower reaches of the stream. And also this hydrophobic layer like repel water, decreasing infiltration and reducing or lowering the base flow, which can impact like in the long run winter stream flow. Yeah, so can you go to next slide, please? Yes, so we as researchers here in Northern decided to like conduct a pilot study to see whether there's a change actually in chemistry after wildfire. So we decided to do this pilot study in Ramp watershed. We picked this watershed because it's in the central Alberta, and also it's close to oil sand development area. And also this program has collected significant amount of data over like 10 to 15 years. So we have a like pretty nice time series data set in this area. So we collected like water quality data and sediment quality data from RAMP program, Regional Aquatic Monitoring Program, long-term river network program, as well as historical wildfire data. And we analyzed physiochemical, metal, and PHS from both water and sediments, basically to identify whether there's a significant change before and after fire, also to identify fire sensitive parameters. So and also we classified these sites into 4 categories: reference sites with no impact, like either wildfire or like oil sand development; just the sites with oil sand developments and oil sand and wildfire, like both impacted areas; and also just wildfires. The idea behind this is just to like differentiate the impact of wildfires from other influences like industrial development. And also we perform some hydrological modeling work to estimate to investigate whether there's an impact on the quality. Next slide, please. I'll quickly go over the like findings because I don't have time to present everything. So we see like a significant shift in like some parameters in both water and sediment samples, and we identify the high erosion and also like higher higher runoff and erosion, like the increasing in like erosion rate, uh, uh, as key driving force or mechanisms, and the continuous monitoring is required to detect these impacts early, and we were able to use like ratios of pH as to distinguish the wildfires from industrial impacts. And this conceptual model shows the source and also the driving forces or mechanisms, and also fate of like metal and pHs. So if you need more details, we can discuss during QA session, or like later on you can reach us. So next slide, please. Yes, and also we performed some modeling studies. Like what we did is just like we implemented a distributed model, and we run the model before fire conditions and after fire conditions to see the impact on quantity. So as you can see, like we have, I have like we use like 2016 fire as like as the scenario for model run. So what we can do, we ran the model before fire and after with land use change, and here I have the hydrographs. Um, as you can see here, so like the hydrographs, so like you could see like significant increase in peak flows, and also this graph shows the significant increase in runoff with increasing the regeneration of fire area. We identify this re, the fire impacted areas regeneration area after 5 years. So the main takeaway is just like we see nearly 10% more runoff after fire and higher peaks after the burn. Next slide, please. So this is regarding surface water, and we did some analysis regarding groundwater. This is like we calculate base flow index, which is related to like groundwater infiltration, the amount of water infiltrating in the ground. So as you can see, like just before the fire in 2016, like there's like the base flow index is just like higher than after the fire, which means like the significant reduction in infiltration after the fire. And this graph shows like the lesser the like BFI, basically higher the increased regeneration area of fire fraction of land use, like lesser the BFA, like look, the infiltration has like significantly reduced after, so it may like impacting a groundwater amount or quantity. Next slide, please. Yeah, so to wrap up, so like we see like wildfires have immediate and long-term effects on quality and quantity of both surface and groundwater. So like definitely a proactive monitoring and strategies to reduce long-term damage is needed to build a resilient watersheds. In order to like develop this resilient watershed, so we need to consider the cumulative impacts, and also we need to work as a group, like the as a group to work towards like resilient watershed. We need to collaborate with communities, researchers, land managers, and policymakers to make it happen. And moving forward, so like now we know this impact on surface water, like, and also like this impact on groundwater quantity wise, like moving forward, we are planning to investigate the impact of wildfires on groundwater. So can you go to next slide, please? Yeah, so we are planning to do this or achieve this goal by creating vulnerability and risk assessment map for Alberta. So like what we're planning to do is just like analyze the existing data sets to make a conceptual model to show like uh, consider like treating wildfire as a trigger, like create contaminant source, pathway, and receptor kind of model, and create a map using like existing data to show the vulnerability of each watershed, like in Alberta. So these maps can be used as a tool to identify higher risk areas, and also we are planning to do some conceptual and numerical modeling to investigate the impact of wildfires on quantity. These models can be used to run scenarios to investigate the impact. And also we are obviously working with communities, like we are closely working with WPACs, Watershed Planning and Advisory Council, because they know their watershed best to achieve this goal. And the ultimate goal is to apply these findings in developing water management strategies for high risk regions. So next slide, please. Yeah, I think that's it. This is the references, and thank you so much. So if you have any questions, you can use Q&A session, and you can post your questions in the chat. Also, I'll post my contact details on the chat. Then you can reach out to Innotech Alberta anytime. So thank you so much.
Thank you so much, Dayal, for sharing those findings and for packing so much into that little micro talk. We appreciate you sticking to the time. Yes, round of applause. Thank you for those nice emojis for Dayal. So we're going to move now to our next presenter, Jen Beverly. Dr. Beverly is an associate professor at the University of Alberta. Her research team is called Wildfire Analytics, and they focus on strategic assessments of fire behavior and fuel hazards. If you're ready, Jen, I will turn it over to you.
Thank you. Thank you for the introduction. And maybe to advance the slides, I'll try a signal with my pen here, so I can keep there's a few animations there, so it might get a little bit complicated. And I see like some of the text in the slides aren't showing up, but hopefully the other ones aren't affected. Yeah, so I'm a wildfire researcher at the University of Alberta, and I'm going to give you a bit of background on wildfires in Canada, and then talk a little bit about some of the things that we're doing to inform fire management. I don't know if Amy can see me. Next slide. Right, so Canada has fire-prone landscapes, and back to the previous slide, please. I think you went ahead too there. Yeah, so Canada has fire-prone landscapes, and I always like to show this in the context of the boreal zone stretching right across the country. You can see that's really where most of a fire activity is happening. These are the burned areas, so the perimeters of the fires. And going back about 100 years, you can see we have a lot of fire in Canada right across the country. Most of it's in the boreal, although you do see, in particular in BC, interior South BC, there's fire down there. But most for the rest of the country, it's really primarily concentrated in the boreal zone. And next slide. And these are the kinds of fires that are natural in the boreal zone. So high intensity crown fires, burning in conifer species, forests like black spruce and jack and lodgepole pine, and they support these high intensity fires. These forests have evolved with fire. They need fire to regenerate. So fires come through, they kill all the trees. These trees are not very resistant to fire. The bark is thin, and it sets the stage for the next stand to regenerate. They're removing the surface biomass, setting basically a seed bed, and at the same time popping open serotinous cones. They are kind of covered with a waxy resin, and the fire heats up the cones, releases and melts the resin and releases the seeds. Then it falls on that prepared seed bed, and you get the next stand, even-aged conifer trees coming in afterwards in this really quite like amazing process. And I like to describe it as it's like photosynthesis in reverse. You've got decades of stored up sunshine and the biomass in the trees, and all of that heat and light is released in just a few minutes as a fire passes through and completely transforms these forests. And it's natural, and it's part of maintaining ecosystem health in these forests. Go to the next slide. Now, in the aftermath, it can seem quite stark, but again, for these species, they've really been built to burn. And for black spruce, you've got these lower limbs hanging down like a wick for fire to access the suspended aerial fuels in the canopy. So it's very easy for fire to move from the surface up into the canopy into that crown fire condition. And for jack and lodgepole pine, you've got flaky bark that also assists with helping fire transition into those high intensity crown fires. So, these are species that have evolved with fire. It's a natural process, and it's part of ecological functioning, and natural disturbances in these areas are key to maintaining ecosystem health. Next slide, please. until it affects people and public safety and other things that we care about. And that could be infrastructure, it could be cultural values, it could be critical habitat. And these images that I'm showing here are impacts to the built environment, people, public safety, and they're all taken from 2023, which was a very severe fire season, of course. And one thing I like to note when I show this slide is that in 2023, we had multiple regions of the country, regions that varied by forest type, that varied by the management intensity and histories, that varied by land use. And that tells us that large scale climatic factors were prominent in defining that season. So when lots of areas that are very, very different are all experiencing severe seasons in a single year, we know that it's a climate issue. And we'll go to the next slide, please. I always like to show 2023 in relation to historical data on area burned, and fire numbers aren't that reliable as a statistic because we haven't done a really good job at recording them in a consistent way over time. So the minimum fire sizes have changed, and not all fires were recorded early on. And the other kind of key thing when you look at the data, the yellow bars are the area burned going back over 100 years. There's a lot of interannual variability. So there's spikes, and then the next year there's hardly any area burned, and that's consistent and normal. So it's really hard to look at a small part of this graph and make any conclusions. We can put it all together, but we know that the early years are probably missing undocumented fires that were never mapped. And so, the data is limited in our ability to understand the pattern of fire and how it changes through time. But one thing is clear when you look at this map is that 2023 is unlike anything that happened before it in terms of area burned. And really, I like to stop and think about this. And basically what that means is we can't rely on the data of the past to anticipate and prepare for the future. And there's nothing about the area burned, and that's sort of one of the basic statistics that we track. Of course, there's lots of other ways we can document fires, but there's nothing about the area burned record that prior to 2023 that would have prepared us for that fire season. And the blue arrow there along the bottom, it delineates a time period that I studied years ago and published a paper to document historical wildfire evacuations, and it was from 1980 to 2007, so almost 3 decades. And over that almost 30 years, we were able to document 209,000 evacuees in total across Canada. Well, there was more than that in 2023 alone. So again, in terms of impacts to people, you can't rely on the past to anticipate and prepare for the future. But I'll also say that you'll hear people say, well, 2023 is what we should prepare for from now on. Well, I don't know. We didn't see it in 2024, and there's nothing about the data that it's an outlier. There's nothing about this that would tell me that I need to prepare for it into the future. And this is just a reality that we're in. We have extreme uncertainty about these processes and climate change and how that's impacting them into the future. And we'll look at the next slide. So what do we do about it? Well, I guess I'll just highlight, you can't rely on where fires were to anticipate where to expect them. So, when we look at 2023, there are places like the outskirts of Halifax experiencing the kind of wildfires that, you don't normally see outside of Western Canada. So, and if you look at the map fires in the past, there's really nothing about that data that would say that we need to worry about it if you're relying on past data of where fires have been. The next slide, please. So what we can do, though, is focus on where the fuels are, because that's the hazard and we know where it is. So even if it hasn't burned recently in the past, if there is fuel there, we know it can burn. So we've developed some real simple tools that are really just based on classifying land cover. So in this case, I'm showing the example of a land cover grid, 100 meters by 100 meters. And if I want to understand the potential for fire to transmit to that white cell, that's my assessment cell in my land base, I just look in the neighborhood around me and say, well, how much of that surrounding going out about 500 meters, how much of that land can send fire to me? In this case, there's 80 pixels around me, and 75 of them I've classified as being hazardous fuels with the green check marks. And so if you click there, Amy, there's a couple of animations. It'll highlight some of the pixels that I have classified as hazardous. So the green ones, those are conifer, the dark green And you click again and again, it'll show, okay, if it's outside of that neighborhood, I don't count it. And if it's a deciduous fuel type, I don't count it. But I can very simply calculate exposure. I can map that for large areas. And here I've just done those calculations and map that exposure from 0 to 100 right across the country. You can overlay the fires that happened since, and you can see that they're very much concentrated in those high exposure areas. So it's a real simple way to map locations where we expect fires to burn, and to pre-identify the locations of the landscape where it can happen. Next slide, please. And so how do you use this? Well, you just take this map and intersect it with any value or thing that we might care about. In this case, and I did this for Dayal, I just took watershed boundaries for hydrologic unit code 6, intersected it, and then you can see, well, here are these areas where you could delineate watersheds and subunits that where you have a lot of highly exposed area, and then could incorporate that into risk analysis. But you could consider this for any value, so it could be mapping critical habitat, for example. Next slide. And the other thing that we've done is like most risk assessments are what we say are omnidirectional, but fire is directional. Fire spreads across a trajectory. Usually it's wind driven. And so we've developed other simple tools to map those trajectories. And so in this example, if you have a point, maybe it's critical infrastructure, or maybe again, it's a critical habitat area that you're worried about, or maybe it's a community, there's a lot more potential for fire in this case to come in from the west than the north. And so we've developed some real simple ways of visualizing that in a consistent way. I think the next slide is my last one. And here's an example of doing that for a community. So this is Jasper. We had done this assessment in 2023 before last year's fire, mapping these directional vulnerabilities for that community, and had ranked it the number 3 top most vulnerable community in terms of those directional pathways. And so these types of tools are real simple ways of identifying where you might do mitigations or preparedness planning, or even for prioritizing response. And I think my last slide is just acknowledging some funding sources and contributors. So thanks for your attention.
Thank you so much, Jen. And we will have lots of time for questions, I think. That was a great presentation. Thanks again for squeezing it into a short time slot. Really appreciate your time preparing that. It looks like something has come up for Joe Gilchrist. I'm not seeing him logged on yet, but I will give a little intro to that story, and I hope that we'll be able to interview Joe at another time and perhaps add that to the recording, because we always like to share the recordings of the webinar on the CCLM afterwards. Joe began fighting forest fires at the age of 15 and worked for the Merritt Fire Devils as the unit crew leader and a full-time employee with BC Wildfire Service. And now Joe is an Indigenous fire keeper, helping to reintroduce cultural burning on the land, and using Indigenous land stewardship and fire and prescribed fire and how they respond to wildfires. So hoping to be able to elevate that story and share it with the CCLM users in the future. For now, I'm going to turn it over to Jessie Lavallee-Whiffen to continue with our panel questions.
Great. Yeah, thanks so much, Shala. I'm also sorry to hear that Joe wasn't able to join us today, but we do, which means there'll be more time for questions if people have questions, so you can go ahead and put them in the Q&A. But we have a few to start to get the conversation going. So my first question will be for Dayal. You talked a little bit about this, but what specific hydrological changes occur in watersheds following a fire? And you talked as well about how these changes affect water quality and availability. What challenges might this also pose on the landscape?
Yeah, so basically when a wildfire sweeps through an area, so it basically alters the entire hydrological cycle, starting from, like the vegetation. So like wildfire, remove the vegetation, like less vegetation means less interception. So like more water falls onto the ground. And also like these wildfires produce these hydrophobic layers. So, and it prevents, water entering into the soil, and basically it repels water and like increasing like the runoff, like more water flow on the ground and like enter into the like surface water systems like rivers and lakes. And when we have high runoff, like means like it carries all the debris, nutrients, and all the pollutants or like contaminants, right, produced by wildfires. So then also like it reduces this hydrophobic layer, reduces the infiltration. It means like less water percolate into the like shallow groundwater aquifers. So, and it means like it lowers the base flow, which is like the groundwater contribution to the stream, especially during winter time. So there can be a like long-term impact on base flow. And also like now the soil, and also like this wildfires like alters the soil properties. So, and immediately after the wildfires, so like we've seen like like the higher sedimentation rate and erosion. And this also like this the higher erosion or higher sedimentation rate, like well, also like this erosion and the sedimentation, the water carry all this stuff, the pollutant, and put it into like the surface water bodies. So when it comes to like groundwater, so there's not much studies on this impact, especially in Alberta and in Canada. But there are some studies showing like this, like long-term impact on groundwater. So like it's very complicated, right? So surface water, you see that's like this hydrological changes right after the fire. But when it comes to groundwater, it takes sometimes weeks, months, and years to reach these contaminants to the groundwater. So, and also we don't know, it's very complicated, like the beneath the surface, we don't know what exactly going on. So like that's, so we can only see like conceptually explain this, like hydrological or hydrogeological changes due to wildfires. Basically, like, and also like obviously, like these pollutants end up in rivers and lakes. And also you see like changes in surface water groundwater interaction, especially when we have like higher sedimentation rate, these sediments make clog, like this recharge areas, like preventing water entering into the, like groundwater, and it changes groundwater surface water interaction as well. So, and also like high evaporation, right? So like when the land is exposed, you see like high evaporation. Basically, this wildfire alters the entire hydrological cycle. So.
Great, thank you. Before I move on to Jen, we did have one question come in that I think is highly relevant to what you're talking about right now from Courtney. What percentage does wetland area in a watershed have to help buffer the effect of fire on water quality and quantity? And would the type of wetland make a difference to this?
Okay, that wetlands is also like very complicated system, right? So, and yeah, we've seen like uh okay, I've never like actually looked into this like impact of like the wetlands, and like the 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 role of wetlands in this all like the scenario. But when I think about like wetlands, wetlands has like uh wetlands are capable of like purifying water and stuff, and also like it's wetland, right? So definitely it reduces the fire intensity. And also like the percentage wise, oh, that I don't have a number, but definitely we are planning to incorporate like the wetlands and their properties into the modeling work moving forward. So I don't have a percentage or like exact answer for that, but we will be examining that moving forward.
Great, thank you for answering that. Sorry, I threw you off guard there a little bit. We can go on to our next question maybe and send it over to Jen. What are key factors that you believe must be considered when assessing values at risk in a given landscape?
unmute myself there. Yeah, it's a great question, and it's a simple thing. Sometimes conceptually, you're like, okay, well, there's values, and I can, as I was showing you with some of the assessments that we do, you can just intersect that with a map where we've assessed the exposure to wildfire. But when trying to interpret that, it can be a little bit more complicated. First of all, you want to consider the characteristics of the values themselves, and are they receptive to burning? For for a building, if you're thinking about the built environment, you can imagine a concrete building that is a value that could be interact with a wildfire, but is the characteristics of the building itself. It's not flammable, so there's the characteristics itself. How receptive is that value? And the value could be in a forest. And so is it a forest that's valued as a timber resource, and then we know it's flammable and it's at risk, and it's receptive to ignition, or is it a forest that's valued for other amenities that it provides, and in which case maybe its fire is part of a natural process. It's receptive, but it won't be necessarily damaged by the fire. The fire might actually be beneficial in terms of maintaining the health of those forests through time. So, and across large landscapes as well. So, there's the characteristics of the value and how receptive it is, and what is the potential for damage if it does ignite and burn. And then once you get past that, it's okay, well, what is the local context? And that really relates to that neighborhood that we talked about, where can the surrounding neighborhood send fire to that value? And that transmission of fire fire is a contagious process. So it spreads through this continuous endothermic, exothermic chain reaction. The fire that's burning has to preheat adjacent fuel and transmit itself to those adjacent fuels, either with that radiant heat or through embers that it can send aloft through the convection column and deposit in advance of the fire. So we know the distances over which that transmission happens. So if you have a value, it's receptive to ignition, there's potential for damage, then you want to look at that local neighborhood. Is there fuel in that, hazardous fuel in that surrounding neighborhood that can send fire to the value? But you can't stop there, because then you have to go out further to the landscape, because consider that situation on an island. You've got a value that can be damaged by fire. It's receptive to ignition. It's surrounded by pine trees, but it's on an island, and fire can't easily get to the island. So there's limited options for fire to actually ignite and threaten the value. So that further out, that landscape continuity, and that analysis of those pathways for fire to move from the surrounding landscape into the thing that you care about, that you've got to have that connection. And that whole thought process has informed the tools we've developed. So we look at that local neighborhood, then we look at the broader landscape, and we try to connect it with these directional pathway mapping.
Sorry, I was muted. Thanks, Jen. I'll go back to Dayal for our next question. What are the next steps for your wildfire research, and how will your findings influence future wildfire and water resource management practices in Alberta?
Yes, so we already identify, the fire sensitive parameters using, after this study. So our plan is just first publish and share this knowledge with, different stakeholders and different government parties, the policy makers and so on, because we have to first, disseminate this knowledge with policymakers as well as the communities. So because now, and also now we know that there's an impact, as I said before, next would be the impact in groundwater, investigate the impact of wildfires on groundwater. So I'll kind of elaborate what we're planning to do. So let's say we have identified these parameters, and then the next would be we need to see whether these parameters even reach the groundwater. So like, the south, because there's like barriers between surface water and groundwater, right? So, and the next idea would be like using existing data set like hydrogeological and like hydrogeological data, hydrostratigraphy, and so on, like create conceptual models to like identify the pathways and receptors. For example, so like this surface water can percolate into shallow groundwater, and if there's a like groundwater dependent ecosystem which depend on like 100% like surface groundwater, there's a possibility to see like a signature or like um, contaminants like maybe after several weeks or months in this GD. But if it is deep groundwater, it's very complicated, right? So it first goes to shallow groundwater. There should be like connectivity between like a surface shallow groundwater and deep groundwater. It's very complicated. Sometimes they are connected, sometimes they are not, right? So like without conceptualizing this, we can like even like think about like investigating impact on groundwater. So the conceptualizing all this stuff, and also like there are data available, but we need to like figure out way to like identify a response unit. For example, we can use like, for example, like the watersheds that like Jen is using, and she's like kind of involved in this our project as well. Thanks, Jen. So like like what the maps she's produced so far are definitely helpful, and also like different layers. For example, AGAS, like Alberta Geological Survey, has those like conceptual models for each hydrogeological units in Alberta, showing 3D version of like the structure or like layers within the Earth surface. So like we can use those models, and also like the data available, like the groundwater data, quality data, and also like other parameters, like whatever available in Alberta. So that would be our first step, like compile all this data set and conceptualize the concept. And then once we figure out this source path the receptor thing, then we are planning to do some like modeling work, actual modeling work. And also like once we have data set, we don't have like baselines for water quality or like any fire related things. So like unfortunately we have like a lot of groundwater data available, but they're not continuous. So like in order we can like perform like conventional time series statistics or analysis. So we might have to go for like complicated Bayesian modeling kind of like techniques to develop baselines before we investigate the like impact. So finally, the numerical modeling is needed, like to investigate the impact of wildfires on especially the quantity, and also like the final product would be a vulnerability map, but it's too complicated. And once we have all the data settled, we are planning to use kind of machine learning techniques to figure out the vulnerable areas or like high risk areas. So it's a very complicated project. So we are planning to use a stage gate approach to like examine this, because it's nothing is going on in this field. So if anyone is interested in like collaborating with us, like we're happy to collaborate, and any kind of knowledge related to this, like especially with communities, indigenous communities or other communities, like small communities, especially in central and northern Alberta, we would like to get your input to this project. And yeah, so, and also like moving forward, like this findings from this research will basically inform the monitoring. So when we've looked into like existing groundwater monitoring data set, the parameters that we identify from like surface impact of wildfires on surface water analysis, we don't see these parameters in groundwater like monitoring programs. Like without that monitoring, we can't say whether there's impact or not. So like basically like we're trying to inform the monitoring program to include these like fire related parameters, see whether there's a change or not. So, and also like these findings will definitely inform like policymakers moving forward if they are willing to collaborate with us. And yeah, so there are a lot of things, but takes time, right?
Thank you. I have one more question for Jen, and then I'll move on to a couple more questions that have been asked by some attendees. Jen, what do you think, or what do you believe are the biggest challenges for the next generation of wildfire researchers and land managers, and how can your current work help address some of these challenges?
Yeah, great question. the key one would be just the uncertainty in the world that we live in. That the landscapes of the past don't exist anymore. Climate of the past doesn't exist anymore, and it's really difficult to predict what's going to come. So that uncertainty, I think, has been really amplified, especially in recent years. The other one is that the fire management challenges of today are really different than they were just 20 years ago. So if you think about 20 years ago, mostly fire management was a concern of provincial and territorial agencies across Canada that manage fires, and they dictated the policy, which is we got to go suppress the fires, and there's always been some effort to accommodate fire for ecological objectives and beneficial aspects of fire where you can do that. You can also save costs, but for the most part, it was the provincial responsibility, territorial responsibility, and they're out there doing their thing. They're managing fire. Today, fires are impacting a much, I guess, broader group of practitioners involved in land management, and the solutions have to come from a much more complex collaborative framework than in the past, when it was fire people doing the fire things, mostly suppressing. But when you want to mitigate fire, when you want to accommodate fire and achieve these other objectives beyond just suppression, it's a lot more complicated, and you have to have a lot more people at the table. And that, I think that part of that too is recognizing that in the past you could have a provincial strategy and objectives around fire that were consistent across large areas or large zones. Maybe there might be a large zone to the north in some provinces where fires weren't actively suppressed unless they threatened people. But for the most part, what the actions that were taken were kind of applied uniformly across large management areas. Whereas today, you can see it's essential that we customize our strategies and policies for specific areas, because the nature of the problem differs regionally, and needs to be addressed in an appropriate way for it's going to differ from one region to the next. And so that idea of more bottom-up solutions that are customized to local circumstances, that are formed by a more diverse group of practitioners and decision makers and affected parties is really entirely different from the way fire management was done just a while ago. So those are a few key things. I could go on.
Thank you. This is a question that I think both you and Dayal could both talk to a little bit. So because fire is a natural occurrence in the boreal and fire is expected to change with climate, what aspects of the fire regime, so this could be intensity, frequency, season, are most concerning or impactful on the groundwater hydrology side, but also for human impacts, like you had talked about evacuations and infrastructure a little bit as well? So yeah, I think this one can go either way if either of you want to touch on either of those pieces.
Yeah, I could speak to the what we see happening with fire, and the example, actually I was saying it to the fire class that I teach this morning. I'm like, well, if you have a bonfire, and that's the way natural fire burns in the boreal forest, it's this intense fire, and you add more fuel to it, you still have a bonfire. So when you still end up with all the trees dying, and that's the natural process, right? So you could have a more intense fire that isn't necessarily differing all that much from what we might have had in the past with climate change, more drought, though you could have a burn severity that's inconsistent with what we've seen in the past. So really deep burning and potentially resulting in transition of that area to a whole other, turning into a grassland and shrubland from a forest, for example. So I have heard of those kind of isolated cases where there has been some evidence of that, but not across broad areas. In general, what I've seen is that the fires are intense. They're burning the way boreal fires have always burned. I mean, there was the Chinchaga fire in the 1950s. It was 1.4 million hectares. That's double the size of the Fort McMurray fire. And there's always been big boreal fires, high intensity fires, explosive fire behavior that's documented, decades into the past. So the sizes of the fires, their intensities, what I've seen in the data is that those things aren't really what's being impacted. It's more that there are more big fires than we used to have. So the fires themselves, the way they're behaving, what they're burning, that they're doing what they normally do. There's possible that there is changes that are happening with some aspects of the fire regimes, and I think that varies quite a bit from one area to another. In general, though, we're getting more big fires as a result of extended drought and dry conditions across large regions, like all of Western Canada or all of Alberta, for example.
Yes. So, and I would say like it depends for sure, but like intensity. Okay, like when it comes to intensity, the intensity affect the thickness or like the hydrophobic layer, right? So like, but we don't know much about this hydrophobic layer, but intensity has a role. We think like, but we have to do some more research to it. But I think like intensity has a role to play when it comes to the thickness of hydrophobic layer, and also like frequency, like because with climate change, the frequency is, like increasing, but there's no time to recover, right? Like it takes time to recover, after the fires, like not just the vegetation, like even the water cycle, it takes time to recover. But if there's another fire, like in 5 years, so like again, like you have to start from the scratch. So I don't know, probably I'm using not right words, but yeah, you have to start from the beginning, right? So but and also like when the frequency is high, so right, the fires adding more contaminants or pollutants, and the residence times, right? So like we see like kind of like disappearing all this like pollutant after like 2 to 3 years, and also like each pH has like different like residence time, but when the frequency is high, like keep adding these like contaminants or like chemicals into the system. So it depends, but frequency and intensity definitely play a significant role when it comes to like impact of wildfires on both surface water and groundwater. So.
Great, thank you guys. This next question goes back to Jen. It says, thanks for the presentation. I noticed you identified the towns of Nordegg and Hinton as high risk. Have these communities taken your findings into account in building on their fire management strategies?
Yeah, so we, yes, I guess. Well, we provided our assessments to both of those communities. Actually, both of those communities were part of kind of in-depth case study work that we did doing these assessment methods, and have reported back to representatives in the communities and provided them with the maps to inform when the next time they update their wildfire mitigation strategy or they have different labels for these across Canada. It could be resiliency plans in some places, but that they can incorporate that information. And that's what it's intended to be used for. These assessments are intended to inform, maybe it's a fuel reduction treatment, and both of those communities already have lots of fuel managed areas where they've gone in and thinned out the forest and removed the lower limbs on the boles of the trees, remove some of the surface fuels to make it harder for fire to transition from the surface to the ground. So the communities can use our assessments to identify where to prioritize mitigation investments, and also to hypothetically explore, okay, if we go and treat these areas, how does that reduce exposure to structures or to other values and that kind of thing. So there's lots of communities, though, that have vulnerabilities, directional vulnerabilities and exposure throughout Alberta. And actually, we've done all these assessments in Ontario as well to help the Ontario government prioritize their mitigation efforts.
Interesting, thank you. This one goes back to both Jen and Dayal. Has there been any research comparing the effects of ecosystem services by wildfire versus clear-cut forest harvesting?
Yeah, so I haven't done work. So in terms of ecosystem services, I guess what are you thinking? There's been a lot of work to try to understand the differences between harvest disturbance and wildfire disturbance. And even in basic ways, like fire is a self-limiting process. So if you have fire out in the landscape, it's removing fuel, and then that burned patch can then constrain the next fire. So there's been a lot of discussion. Well, can harvesting provide that same effect, that protective effect. And so actually I have a PhD student who's trying to better understand what happens when fires and harvests interact, for example. But there's also been there's what they call kind of ecosystem or disturbance-based management, where you're trying to look at wildfire and that type of disturbance as a way to inform the way you harvest. But in general, I mean, these are very different types of disturbance. And there's also different like post-harvest treatments that are done. Is it replanted? Often you have conifer being replanted in a matrix of grass, Calamite grostis. That's quite flammable, of course. So it depends on which ecosystem services you're interested in, but there is a lot of work trying to compare those disturbance types, the natural versus anthropogenic.
Yeah, I have nothing more to add. Yeah, so Jen knows better than me on that part of the equation, I would say. So
Sounds good. No worries at all. I think if I'm seeing correctly, we may actually have Joe joining us. So I may cut off our question period there if he's able to join us. We'll just give him a moment, and not to ignore the last question in the chat, but I think Dayal, you may have touched on it in one of your last answers as well, just related to like how long wildfire areas take to recover. So I think you touched on it a little bit, but if you wanted to say anything else, you can add now too.
It's a very complicated question. So when we try to implement or plan this study, we were trying our best to find a timeline to differentiate new fires, old fires, recently burned. But it's very complicated. What we ended up doing is just we use parameter residence time to kind of divide these fires, because it's very complicated. It depends on the climate, it depends on the area, it depends on the geography or geology. It's very complicated. What we do is just use residence time for each pH to see okay, how long it lasts, and then we calculate or do the estimate the impact. So it's a very complicated question, and we don't have exact answer to this much years, with 20 years, 25 years. It depends.
Great, thank you. Okay, I will pass it off because Joe has joined us. Thank you so much, Jen and Dayal, for answering all of our questions. We appreciate you taking the time and providing some insight on both of your areas. So I'll pass it over to Shala or Amy to introduce Joe and his presentation.
Thank you. And welcome, Joe. I'm so glad you could join us. We're really honored to have Joe Gilchrist joining us today. Joe began fighting forest fires at the age of 15, and Joe has worked for the Merritt Fire Devils as a unit crew leader, as well as a full-time employee with the BC Wildfire Service. Joe currently resides in Skitchitsin as an Indigenous firekeeper, where he continues to learn and teach about cultural burning and how it is used in Indigenous land stewardship. If you're ready, Joe, please go ahead.
Okay, yeah, thank you. A newly designated term for Indigenous people for an old practice of cultural burning is firekeeper. And I have been designated as a firekeeper with my background with Wildfire Branch, fighting forest fires. But what made that kind of a different avenue of that is my former boss at the Merritt Fire Zone, Tom Lacey. He, in the 1980s, he believed in cultural burning, and he wanted to learn more and more. And so as I went through my career, he would always give me different instructions. And one of the instructions that I had with the Unicrew, the Merit Fire Devils, when we traveled all over Canada and BC, was to talk with other people from other nations, Indigenous nations, and ask them about fire and uh, what they burned and why they burned. And I would report that back to my boss after each trip, and that we went on for firefighting. And um, he just gained more and more information. And um, in 1996, I went to the St. Mary's Residential School for 16 weeks of government in-house training to become a fire prevention technician. And at that time, that was the it was in Mission, BC. It was the place where the tribal police uh, did their training. It was the Indigenous Justice Institute. Um, so after 16 weeks, I completed that and started full time with BC Wildfire Service in Merritt Fire Zone. And my first instructions, my first job was to go through truckloads of fire reports that were in file boxes and get the Latin long and the geographic location, the name of the fire, the cause of the fire, and put it onto a spreadsheet, which took me quite a few months to do. And at the end, I presented that database to my boss, Tom, and he put it onto GIS and came up with a bunch of dots on the map. And the fires that started in the springtime that were cultural burning, indigenous use of fire, miscellaneous unknown, and hot start. Uh, those fires were in the valley bottoms in the springtime. And then um, the other ones that were in the fall were um, up in the higher elevations where mushrooms and hunting areas and huckleberries and different kinds of berries were burned in the higher elevations in the fall time. And so from that, we were able to change the way that we fought fires. Um, we had a lot of human starts that um, if we worked with the indigenous people and we would cut that down and we would um, have it all mapped and we would expect fires to start there. So then we would, instead of going at full attack with air tankers and bulldozers and uh, uh, a lot of crew members, generally it would just be myself plus three, and we would go down and we would find roadways, natural breaks that were around the fire, and we would use those natural breaks rather than putting in a lot of guard. We'd dig as little guard as possible so we didn't wreck up or tear up the terrain. And then we would burn the fire out to those areas. And we were creating a mosaic of different um, uh, I guess fuel types. We would reduce the fuel there, and the spin-off effect was that the community was safer from fires because there's less fuel, and the indigenous people were happy because whether they're burning for medicine or burning for food or burning for the animals that they hunted, um, it enhanced the forest. This practice of cultural burning has been done for thousands of years, and in a lot of in all the cases that I know of, all across Turtle Island, North America, all First Nations used fire. Um, uh, so the last 100 years plus, fire has been taken out of the hands of Indigenous people. It's been made illegal to burn. You can still burn on reserve, um, but off the reserve it gets really complicated because of bureaucracy and cultural differences and just laws and legislation. You can still, you can go to jail. You can end up with a big bill if you're caught burning off the reserve, and especially if you cause damage to property and things like that. So, um, so somehow those practices that were done for thousands of years that um, really made the land giving mother for us. And now what we have is a forest that is choked. It's pitiful. Uh, the trees are getting, in some cases, too old, and in other cases, it's too overgrown. The little trees are taking over. It's causing ladder fuel. There's disease. There's bugs. Um, and a lot of times you just can't walk through the forest. And now what we're seeing is catastrophic fire with climate change, especially with our summers are getting longer. They're getting hotter. They're getting more intense storms and stronger winds. Uh, and we're starting to see fire where we never seen fire before, like down on the coast, on the islands, and it wasn't that way before because all the fuels were taken care of. Um, and so just in the last few years now, the overgrowth of the forests has just made it dangerous, and the practices of tree planting, the trees too close together, and it just caused one monoculture so that a fire is able to go for kilometers and kilometers, like we saw from the Lytton fire, which burned all the ways to the Nicola Valley and jumped the Nicola Valley, which is about 60 kilometers. And it did that in about a month, I think, a month and a half. And with the smoke that we get now, causing disruptions in tourism and, our daily lives where you can't go outside for more than 20 minutes. Um, and it's also hinders the firefighting efforts because you can't fly aircraft and helicopters, fixed wing and helicopters to fight the fires, and it becomes dangerous for the crews if they can't see what's going on. So with multiple catastrophic fires going on, not just one, now it's the whole province, is affected by different fires all over the place, but um, the smoke just sits down under high pressure and causes all kinds of uh, operational problems for firefighters. And a lot of cases, they can't do anything, and the fire just does what it's going to do until they can finally get in there safely. Um, of course, evacuations and things like that with the communities is becoming uh, more prevalent with, even with people not being able to go outside with smoke. Um, it's a real problem, and how many tourists cancel their trips to BC because, power outages, travel disruptions on highways and just closures of the forest. And with climate change, it's not going to get any better. It's going to get worse. Like I was saying, even on the coastal lands, we're beginning to get fires now. And those fires on the islands now are going to be more dangerous as we see more drought and longer periods of heat. With the in Kelowna, with that fire, the duff layer is probably about 10 to 15 centimeters deep, and down on the coast where uh, the fires are just beginning now, the duff layer is 1 to 1.5 meters or even thicker. Uh, that duff layer is the driver of the intensity of the fire, and when that dries out, um, if the fires are going to be super, super intense, and the the ladder fuels, the trees that you have down there, they're twice as tall as the ones in the interior, at least twice as tall. So, with the lack of escape routes and things like that, we're going to be looking at really dangerous fires um, in the coastal areas where, a lot of the population lives. Um, so to bring back cultural burning and bring back the indigenous land stewardship and practices on the land that reduce the fuel, um, it's going to be a real education for the public and the government, just to change the laws and things like that to allow indigenous use of fire again on the land, and just that practice of having safe fire in the springtime and the fall time. And you can even burn in the wintertime. If you have too much fuel, you can pile it and burn it in the winter when it's rainy or when it's snow on the ground in a safe manner. In the springtime, the fires are really uh, a lot less intense than you see during the summertime. Just as the fuels dry, right now is becoming uh, our burn season, which would last until about June, when the June rains traditionally came. The Up until June, till June would be times to burn different areas, and then in the fall time, it used to be about the middle of September. Up until the snow flew, you could burn. Those are kind of changing now with climate change. It's a little bit more trickier to burn, but we can't just do nothing any longer because the fires are getting far too dangerous. And with climate change, it's it's just forecasted to get worse and worse. So the only thing that we could really do is manage the fuel and bring water back. Um, and what I mean by bringing the water back is because there's so much trees in the forest, the ponds that were once there have dried up because there's just far too many trees and vegetation. So once you get that under control, and then the ponds should fill back up again, with we do have some rain events that do happen that are really bad too. And if you bring fire back to the riparian areas, the along the creeks and rivers, um, it's been also not burned for uh, 100 years, so it's missed 25 burn cycles. It should burn every 4 years. The roots are coming up because the all that rot of the fuel layer um, is on top. It's not going down into the ground, so the roots are actually coming up. And in the past, it was burned every 4 years so that the nutrition went down into the ground with the rain, and the roots went down, and it helped to strengthen the banks of the creeks and rivers, and also it kept it healthy, a healthy riparian area for beavers, which were almost hunted to extinction. So you can't just bring beavers back because there's not enough food. One beaver eats 100 trees per year. So you have to have a healthy riparian area first and then bring the beavers back. So it's a lot of work to do this. It's not just a one-time uh, only kind of a thing where you throw money. It's it's a way of life where fire becomes a part of the society again, and to to teach the people that a little bit of smoke in the spring and a little bit of smoke in the fall time and smoke during the winter is a lot better than catastrophic fire in the summertime.
Thanks very much, Joe. That was so much knowledge that you shared with us already. Can we ask one question as well that we had prepared?
Yeah,
Okay, Jesse, I'll turn it over to you for a question for Joe.
Sounds good. Yeah, thank you so much, Joe. Um, what do you think are some of the ecological and cultural consequences of not being able to use fire management as a tool, and how can these be addressed in collaboration with broader management strategies?
right. Yeah. So if we don't do anything and we allow fire to do what it's going to do in the summertime, of course we're gonna have a lot of loss from property, but another thing would be, like I said, the smoke for ourselves as residents, but our visitors that come for tourism will be affected. Um, the long-term effects are landslides and just areas where the forest is actually burned so hot that it's going to take a long time for the forest to come back uh, because it just burns so hot that the soil layer is sterilized. Um, and what was the second part of that? It was about government or
Yeah, how can we address some of these consequences in collaboration with different land strategies? So yeah, so that could be government, community, yeah, some of those
yeah,
layers.
yeah. So definitely education is going to be key for the children right now to start learning that cultural burning, uh, indigenous land stewardship, and fire is a tool that can be used in the springtime and the fall time and the winter time. That so that when they grow up, that is more acceptable than it is right now. We need to educate the public more now to become more uh, accepting of indigenous land stewardship and fire as a tool, and the springtime and the fall time. That there will be a little bit of smoke, but a lot of times you can choose which day you're going to burn, and the days you're going to burn, you want good venting so that the smoke just clears and it doesn't really have an effect. But I've seen that sometimes at nighttime the smoke will sit, and we want to try to stay away from all of that and try to have it so that it has very little effect on the the public as a whole. We need to change all levels of government, um, because you just can't burn off the Indian Reserve, and the fire permit takes about 3 to 5 years just to get a fire on the ground, which is not acceptable. We need to think large areas. My boss, Tom Lacey, in the Merritt Fire Zone, which is 1.4 million hectares, from the U.S. border, just about to Kamloops, and then to Lytton, and then over just to the mountains above Kelowna. That big area is 1.4 million hectares, and he would say that just for the Merritt Fire Zone, we would have to burn 200,000 hectares per year in a rotation, so that every 7 years, um, the entire area would be burned. And so if you put that all over BC, it's a gigantic job, which is going to take a lot of collaboration and a lot of public buy-in from everybody to to accomplish our own safety of our communities. There's one way of that kind of thinking, and that's called the 7 generational thinking that Indigenous people use. You take the stories of the land where you're living, of Indigenous people, as far back as can be remembered, through stories and through songs of how the land used to look and how it was used, where berries were picked and where medicine was, and the hunting areas and fishing areas and all of that. It was all burned differently. You take those, you look at how the land is right now and where it needs to improve, and start applying from their community out, and then be able to pass on that knowledge, and to your children, their children, and their grandchildren that aren't even here yet, that can't speak yet. And by doing that, you pass on good air, good land, good water, and a healthy environment that is giving to us and them when they arrive. And if we don't do that, then we're going to hand them the mess that we have right now, and they'll have to deal with the consequences of inaction.
Thanks very much, Joe.
Thank you.
I'm going to wrap us up now, if that's okay, Jesse. I want to thank all of the presenters. We heard important takeaways from Dayal about monitoring groundwater for fire parameters. Lots from Jen Beverly about how to mitigate and even accommodate fire if we have other objectives beyond suppression, and how we may need some customized strategies and policies from one region to the next. Also, Joe shared so much about the benefits of applying cultural burning on the landscape, and a call for some education in the future and policy change around bringing more cultural fire on landscape. That was a fantastic discussion. Thank you, Jesse, for moderating the questions. Right now, Amy's going to put a survey into the Q&A, and we're hoping you can fill that out to give us some feedback on the survey and let us know who the CCLM users are. We're always really, really looking for that information. Please stay tuned by checking out the CCLM for more knowledge exchange webinars. We do 3 to 4 per year, and you can also go to the CCLM portal to find other events from all of the collaborators and associate members, as well as all of those resources, over 3,500 resources that we hope will help you do the work that you do. Have a great afternoon, everyone. Thank you so much again to Joe Gilchrist and Dayal and Jen Beverly for our presentations and everyone for attending today.